The first 4 steps of the WWC's review of a cluster study examine the credibility of the study's evidence of effects on individuals. The first 3 steps determine whether a cluster RCT is eligible to meet WWC Group Design Standards without reservations. These steps assess 3 requirements. First, the cluster RCT has to have low cluster level attrition. Second, it has to limit the risk of bias due to joiners. Third, it has to have low individual non-response. We'll dig into each of these requirements more in a moment. The 4th step provides one way for other cluster RCTs, those that do not meet these 3 requirements, and cluster QEDs to meet WWC Group Design Standards with reservations. To receive this rating and satisfy WWC standards for evidence of effects on individuals, these studies must establish that the individuals in the analytic sample were equivalent at baseline. Studies that cannot establish equivalence of individuals may still meet WWC Group Design Standards with reservations by satisfying WWC standards for evidence of effects on clusters in steps 5 to 7. The first step when reviewing a cluster study is to determine whether it is an RCT with low cluster level attrition. Recall the attrition standard that was introduced in the attrition module, which is Module 2, the same attrition standard that is used to assess attrition for individual level group design studies is applied to clusters. This includes applying the same optimistic and cautious boundaries for attrition, which are specified in review protocols. Cluster RCTs must have low cluster level attrition in order to receive the highest rating of meets WWC Group Design Standards without reservations. Let's walk through an example of calculating cluster level attrition. A study randomly assigned 10 schools to a reading intervention and 10 schools to the comparison condition. There were 50 second graders in each school at the time of random assignment. The study team collected outcome data from only these students. All of the intervention schools contributed outcome data to the analysis, but one of the comparison group schools refused to allow the researchers to collect outcome data. In total, the researchers collected post-test data from 500 intervention group students and 375 comparison group students. The review protocol uses the optimistic boundary for attrition. Let's work through this example to determine what is the overall attrition rate for the clusters? What is the differential attrition rate for the clusters? Does this example have low cluster level attrition? Here is an illustration that organizes the information provided in the example. 20 schools were randomly assigned, including 10 intervention schools and 10 comparison schools. At the time of outcome data collection, there are 10 intervention schools. One comparison group school refused to allow data collection, which means that outcome data were collected for only 9 comparison schools. For cluster level attrition calculations, we don't need to know how many students were enrolled in the schools. To calculate overall cluster level attrition, first we need to determine how many clusters left the sample. We have outcome data for 19 of 20 schools, so 1 cluster is missing. 1 out of the 20 gives us an overall attrition rate of 5% at the cluster level. Now we need to calculate differential attrition. Researchers were able to collect outcome data for all 10 schools in the intervention group, so there was no cluster level attrition. For the comparison group, data were collected for 9 schools, meaning 1 school was not included. 1 of 10 equals a 10% attrition rate for the comparison group. Calculating the difference between the 2 groups' attrition rates gives us a 10 percentage point differential. Our example has 5% overall and 10 percentage point differential attrition at the cluster level. Using information from the WWC Standards Handbook, under the optimistic boundary for attrition, the maximum allowable differential attrition is 10.5 percentage points. Therefore, cluster level attrition is low, satisfying the requirement in Step 1. Cluster RCTs that have low cluster level attrition must meet 2 more requirements to be eligible for the highest rating. In Step 2, the WWC assesses whether joiners represent a risk of bias. For a cluster RCT to be eligible for the highest rating, Any joiners present in the analytic sample must not represent a risk of bias. First, the WWC never considers joiners to pose a risk of bias when the joining occurred before individuals knew the randomly assigned conditions of the clusters. This is because the decisions that led to these individuals joining clusters could not have been affected by the intervention. But joining that occurred after random assignment took place could pose a risk of bias. Each review protocol specifies whether there is a risk of bias from all joiners, late joiners, or if no joiners pose a risk of bias. If only late joiners pose a risk of bias, the review protocol will also specify the period used to distinguish between early and late joiners. For example, early joiners might include those individuals who enter a cluster within 6 weeks after the study begins, and late joiners might include those individuals who enter clusters after the 6-week period. A review protocol can specify this information for all of the interventions that are likely to be reviewed under that protocol, or separately for particular groups or types of interventions. When the intervention is likely to influence whether an individual joins an intervention cluster after random assignment, the WWC considers there to be a risk of bias associated with all joiners after they know the results of random assignment, whether early or late. The school turnaround intervention from earlier is an example of an intervention that is highly visible and might influence which schools students attend. The WWC would consider all joiners in a study focused on this type of intervention to pose a risk for bias. Sometimes, individuals who join clusters soon after the intervention begins are unlikely to have joined the cluster because of the intervention, but later joiners might have. For example, a study of a teacher mentoring intervention might implement random assignment in the summer before the intervention begins in study schools. A mentoring program may be unlikely to affect where students attend school. Students who move into study schools may do so because they have just moved to the neighborhood, rather than because of the intervention. Therefore, the study could collect school rosters early in the school year, but after random assignment, and consider the students on those rosters as good as randomly assigned. However, there may still be a risk that students who join study schools later in the school year could have joined because of the intervention. Finally, when studies test low-profile interventions that are unlikely to cause individuals to join clusters, the WWC does not consider any joiners to be a risk, whether they are early or late joiners. For example, a change in recess programming is unlikely to influence where students attend school. When no joiners pose a risk of bias, all joiners are considered as good as randomly assigned, no matter when they join the clusters. Even if the protocol indicates that some joiners pose a risk of bias, the study can still limit the risk of bias due to joiners. A study with a risk from early and late joiners based on the protocol can limit bias by excluding all joiners from the analytic sample. A study with a risk of bias only from late joiners can limit bias by excluding all late joiners from the analytic sample, but can include joiners who entered during the early period. In sum, to be eligible for the highest rating, a study must either exclude all joiners from the analytic sample, that is, analyze only the stayers, or include in the analytic sample only joiners who enter during periods not associated with a risk of bias. This is the second of 3 requirements that cluster RCTs must meet to be eligible for the highest rating. A study that includes any joiners in the analytic sample who entered during a period associated with a risk of bias is not eligible for the highest rating. The third requirement for cluster RCTs to be eligible for the highest rating is to have a low rate of individual non-response. This requirement uses the attrition standard used for individual-level group design studies, but with 2 differences. First, the attrition standard is applied only to individuals within remaining clusters, meaning the clusters that are included in the analytic sample. If a cluster were to drop from the study prior to follow-up, the WWC does not include the individuals from that dropped cluster when measuring individual non-response. In the example we used to calculate cluster-level attrition in Step 1, one of the 10 schools from the comparison group dropped from the sample. In this example, individual non-response would only be assessed within the 10 intervention schools and the 9 remaining comparison schools. A second difference from the attrition standard used for individual-level group design studies is how the WWC calculates the denominator. Although the overall and differential individual non-response rates are calculated using the number of individuals in the analytic sample as the numerator, the reference sample used as the denominator in the attrition calculation depends on the risk associated with joiners specified in the review protocol. The WWC refers to sample loss of individuals from clusters as individual non-response and not individual level attrition because the reference sample is not always the randomized sample. Attrition refers only to the loss of units subject to random assignment. Depending on this risk, the WWC allows one or more of 3 reference samples. When all joiners pose a risk of bias, the only acceptable reference sample is the individuals who are in the clusters at the time of random assignment. When late joiners pose a risk of bias, but early joiners do not, the WWC can also assess individual-level non-response using another reference sample, the individuals on rosters collected during the early period. For example, if classrooms were randomly assigned over the summer, rosters might not have been collected until the fall. When early joiners are not a risk, the WWC can assess individual-level non-response using individuals on these rosters to form the reference sample. Finally, when there is no risk of bias associated with joiners, a third reference sample is allowed in addition to the previous 2, counts of individuals present within clusters at the time outcomes were measured. For example, a study might report counts of the number of students in schools at the time the school administered an achievement test. The table shown here summarizes the permitted reference samples. But remember, no matter which reference sample the study uses, the WWC counts only the individuals within the clusters that remain in the analytic sample. An acceptable reference sample for the WWC must meet one additional requirement. All members of the analytic sample must be present in the reference sample. So if any individuals who join clusters are included in the analytic sample, it is essential to use a reference sample identified at a point in time after the joiners entered clusters. This requirement prevents a study from having low individual non-response only because joiners replaced all of the individuals who left the study. Sometimes a study might report counts for more than one acceptable reference sample. In this case, the WWC calculates non-response based on the reference sample from the earliest period. For example, consider a study that randomly assigned classrooms to conditions over the summer. The study collected rosters twice, once at the time of random assignment and again on the first day of school. If the analytic sample includes no joiners, the WWC would use the rosters from random assignment, the earlier period, as the reference period for individual non-response, no matter what joiners the review protocol identifies as a risk. If a cluster RCT has a low rate of individual non-response and meets the previous 2 requirements, then the study is eligible to meet WWC Group Design Standards without reservations. It is possible that a cluster RCT will not meet one of the 3 requirements necessary to earn the highest rating. If a cluster RCT fails to meet one of the conditions discussed in steps 1 through 3, then the study must establish equivalence of the analytic sample of individuals in order to meet WWC Group Design Standards with reservations and satisfy WWC standards for evidence of effects on individuals. Cluster QEDs must also establish equivalence in this manner in this review. Reviewers assess baseline equivalence of individuals using the same baseline equivalence standard discussed in the Baseline Equivalence module, which is Module 3. The WWC refers to this requirement for cluster studies as baseline equivalence of individuals to distinguish it from the baseline equivalence of clusters requirement in Step 7. The WWC requires reviewers to assess baseline equivalence of individuals on the exact analytic sample of individuals and use individual-level standard deviations rather than cluster-level standard deviations. If a study cannot establish equivalence of individuals, it may still be able to meet WWC Group Design Standards with reservations by satisfying WWC standards for evidence of effects on clusters. This concludes the 4 steps in the review to satisfy WWC standards for evidence of effects on individuals for a cluster study. After completing a few knowledge checks, we'll move on to discuss the process of the review to satisfy WWC standards for evidence of effects on clusters. Knowledge Check 3. Before the school year started, 14 ninth grade classrooms were randomly assigned to receive either a supplemental science intervention, 200 students, or business as usual instruction, 175 students. Due to scheduling changes, 30 students left the intervention classrooms and 30 new students joined in the second week of school. In the comparison classrooms, 45 students left and 35 students joined in the second week of school. A standardized science test was administered as the outcome measure, and all students in the classrooms took the test and were included in the researchers' analysis. The study is reviewed with a protocol that uses the cautious boundary for attrition and specifies that all joiners pose a risk of bias. What is the highest rating this study is eligible to receive from the review to satisfy WWC standards for evidence of effects on individuals? A. Meets WWC Group Design Standards without reservations. B. Meets WWC Group Design Standards with reservations. C. Does not meet WWC Group Design Standards. B is the correct answer. The study is a cluster RCT but does not meet all requirements needed to receive the highest rating. The analytic sample included students present in the study at the time of random assignment and those who joined after random assignment. Because the protocol specifies that all joiners pose a risk of bias, the presence of joiners in the analysis prevents the study from being eligible for the highest rating. The study could potentially meet WWC Group Design Standards with reservations in the review to satisfy WWC standards for evidence of effects on individuals if the students in the analytic intervention and comparison groups, including students who join the classes after random assignment, satisfy the baseline equivalence requirement. The study is not eligible to earn the highest rating of meets WWC Group Design Standards without reservations. Choice A is incorrect. Because the study could potentially meet WWC Group Design Standards with reservations if it establishes equivalence on the analytic sample, choice C, does not meet WWC Group Design Standards, is also incorrect. Knowledge Check 4. You are reviewing a cluster RCT under a protocol that specifies that late joiners pose a risk of bias, and the individuals who join clusters 6 weeks or later after the start of the school year are considered late joiners. The study randomly assigned classrooms to conditions on August 1, before the school year begins. The study authors administered a pretest to all students present in the classrooms on August 31, during the first week of school. Study authors did not collect information on the students present in the classrooms before the date of the pretest. The intervention was implemented throughout the school year, and students were administered a student achievement assessment at the end of the year on May 31. Although some students joined schools after random assignment, the study limited the analysis to include only students who were on school rosters collected at the time of random assignment. There was no cluster attrition. When calculating the rate of individual non-response, what reference sample should you use? A. Students present in clusters at the beginning of the school year, August 31. B. Students present in clusters at the end of the school year, May 31. C. Individual non-response cannot be assessed because the study does not report on an allowable reference sample. A is the correct answer. Recall that the reference sample depends on risk associated with joiners specified in protocol. The review protocol specified that late joiners pose a risk of bias, so the WWC standards would allow one of two reference samples: students subject to random assignment and students present in clusters in the early period. In this study, the study collected August 31 rosters, which is during the early period, so the WWC would use students present in clusters at the beginning of the school year when calculating the rate of individual non-response. B and C are incorrect answers. B is incorrect because students present in clusters at follow-up is not an acceptable reference sample when late joiners pose a risk of bias. C is incorrect because students present in clusters at the beginning of the school year is an acceptable reference sample when only late joiners pose a risk of bias.